Okay, this is 5.2, exponential equations. And so let's start with some equations that you might be a little bit more familiar with. So maybe something like 3x minus 4 equals 11. Whatever values of x that you can substitute in that make the equation true, we call that a solution. One way that you can figure out what value that is by guess and checking. So you would look at this and you'd say, let's try 2. And you'd plug it in for x, and 2 doesn't work. So then you'd say, well, let's try 3, let's try 4, and let's try another number. Guess and check can work in simple situations, but as situations become more complicated, guess and check becomes infinitely improbable. So what we did is we invented a procedure, an order of operations which we perform that sort of spit out the correct answer. So it's like, okay, if you're given this type of equation, you do these steps, you'll get the answer. So in this specific example, first step is add 4. So that's going to give you 3x equals 11 plus 4, or 3x equals 15. So that's the first step, was to add 4. What's the second step? Divide by 3. And when you employ that, you get 3x equals 15. We're going to divide both sides by 3. These cancel. And you get x equals 5. And this is your solution. X equals 5. And you could take that solution, you could plug it back into the original equation, you'd see that it's true, and everybody's happy. When you added 4 to both sides, you employed something called the addition principle of equality. And when you divided both sides by 3, you employed something called the multiplication principle of equality. The addition principle of equality says you can add the same thing to both sides of an equation and everybody's cool. The multiplication principle of equality says you can multiply or divide both sides by the same number and everything's cool as long as that number's not 0. If we have an equation with addition and subtraction, we know how to solve it. You add and subtract something for both sides. We also have taken care of any problems that involve multiplication and division. If I give you any type of equation with addition, subtraction, multiplication, division, you should be good on solving it by using these two rules. Now we're at the point of exponents. And we have to come up with a procedure for solving exponents. So when it comes to exponents, let's say that we had an equation like 2 to the x equals 16. And we want to solve this. Now notice there's no addition, no subtraction, no multiplication, no division. So those techniques that we used before cannot be used. So now we have to come up with a new technique. And again, one technique is guess and check. You take 1, you plug it in, see if it works. No. 2, plug it in, see if it works. No. 3, no. And so again, that guess and check quickly runs out of steam. What we're going to employ is something called the common base of equality. And the common base of equality rule says that if you have a base b to the x power and it's equal to another base b, the same base, to the y power, then it must be that x equals y. If you have the same base, if you have a common base, then whatever the exponents are have to be equal to each other. So what we'd like to do with this situation is we need a common base. So 2 to the x is just 2 to the x. That doesn't really change. But could we rewrite 16 as a base 2, 2 to some power? And the answer is yeah, we can. What can we write it as? 2 to the 4th power. 2 to the 1st is 2. 2 to the 2nd is 4. 2 to the 3rd is 8. 2 to the 4th is 16. So we're going to rewrite 16 as 2 to the 4th power. And now look at this. We have a common base, x equals 4. And that's our solution. We sort of look at this one and it's kind of like, well, this looks like it's going to be a base 5. So what I'm going to do is I'm going to write out the first couple powers of 5. Just to kind of refresh my memory on what these powers of 5 are. So 5 to the x stays the same. That's 5 to the x. And 25, oh, look at this. I can rewrite 25 as 5 to the 2nd power. And now I have a common base, x equals 2. So when you take a look at this, you see that you've got a 16 and an 8. What base do we want to rewrite these in terms of? If we did base 4, that means we're going to rewrite 4 to the 1st, which is 4, 4 to the 2nd, which is 16, 4 to the third, which is 64. How do I get the 8? I can't create an 8 through the powers of 4, but base 2, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. I can rewrite 16 and the 8 in terms of base 2. So we're going to go base 2. So I'm going to take this 16 and I'm going to rewrite it as 2 to the fourth to the x power equals 2 to the third. And notice how I took 16 and I just rewrote it. I substituted in for the 16 2 to the fourth power. You still have to raise that 2 to the fourth power to the x power because 16 was raised to the x power. Okay, so it's a substitution. So now we apply the rules that we learned yesterday, specifically the power rule of exponents, which says when you raise an exponent to an exponent, you multiply the exponents together. So this is going to become 2 to the 4x equals 2 to the third. And now we have a common base. 4x equals 3, and then we divide both sides by 4, and we get x equals 3/4. If you take a look at this one, what's the base?
3.
Yeah, this smells like base 3, right? You got a 27 in there, you got an 81. So I'm just going to write out real quick the powers of 3. So there's my 27, and there's my 81. So now what I'm going to do is just a simple substitution. I'm going to rewrite 81 is 3 to the fourth power, and I'm going to rewrite 27 is 3 to the third. It's just a simple substitution. Now let's employ those rules we talked about yesterday to simplify this. 3 to the fourth to the 2x is going to become 3 to the 8x power, 3 to the negative third power. So we're going to employ rule number 3 that we talked about, which is negative exponents reciprocate. The other way of saying that is if you reciprocate, you have to change the sign on your exponent. So 3 to the third downstairs becomes 3 to the negative third when you move it upstairs. And now check this out. We have like bases. So that means we could write 8x equals negative 3. Divide both sides by 8. X equals negative 3/8. So I'm going to use this table. And I'm just going to do a substitution. So I'm going to rewrite 625 as 5 to the fourth power to the x minus 1 equals, and I'm going to rewrite 25 as 5 squared to the 4x power. So we're going to use the power rule of exponents. And so this is going to be 5 to the 4x minus 4 power equals 5 to the 8x power. And now you have a common base. So that means the exponents are equal to each other. So we have 4x minus 4 equals 8x. Shuffle some things around. Negative 4 equals 4x. Divide both sides by 4. X equals negative 4 over 4, which is negative 1. So identify the common base, rewrite the problem with that common base, and then simplify your exponents using usually the power rule of exponents. If we give you a problem that is like 2 to the x power equals 8, you can solve this because you can rewrite 8 as 2 to the third power, and now you have a common base. If I have 2 to the x equals 7, we can't solve this one in chapter 5. You have to wait till we get to chapter 6 in order to solve this type of problem. So what we're showing you right now are problems that are rigged. They're nice problems. You're going to be able to get a common base. So anticipate that. Anticipate the numbers having a common base.